Hi everyone. Okay, for this Truss analysis, we use the method of joins, and this one is second example. Okay, my name Dr. Nuswada. Okay, now we go for the questions. For this example, we need to find the forces at member AE. Okay, member forces for member AE and member ED only. Okay, using the method of joins. In the given truss, the support A is pin and at support C is roller. Since support A is on the pin, therefore it will have both horizontal and vertical reactions. So we have HA and VA at support A. Support C is roller, therefore it will have only vertical reactions of VC and no horizontal reactions. If you refer to this truss, it is subjected to a uniformly distributed load at certain distance only, about 3 meters from joint E, with a value of 40 kilonewton per meter. At the same time, it is loaded with a concentrated horizontal load of 20 kilonewton at joint D. Okay, now, prior to determine the forces at members AE and ED, firstly we need to calculate the reactions at supports by using static equilibrium. Okay, for the determination of reactions, we use moment equilibrium equation, vertical equilibrium equation, and horizontal equilibrium equation. We first take the sum of moments at joint A to be 0. We do this by ignoring all members and just looking at the loads and supports in the truss. Okay, for taking moment at A equal to 0, in this case, clockwise directions become positive. Meanwhile, for anti-clockwise become negative. Okay, for the UDL, 40 times 3 is 40 times 3 become point load at center of this UDL. 40 times 3 equal to 120 kilonewton. Okay, become 120 kilonewton at center of this UDL. And then distance from this point load to point A become 3/2 plus 2 meter. This one. And for this UDL will rotate in clockwise directions. That's why positive sign here. And then for the horizontal load, 20 kilonewton, this load will rotate in anti-clockwise. And then, that's why negative 20 times 2 meter. 2 meter is vertical distance from D to A. 2 meter. Minus vertical reaction at C times 12. Minus because this vertical reaction will rotate in anti-clockwise and 12 meter is distance from C to A, 12 meter. Now we got this equation. So from this equation, vertical reaction at C becomes 31.67 kilonewton. The positive sign at this value indicates that our assumption in these directions of VC was correct. Okay, now we go for vertical equilibrium equation, or we take the sum of the forces in the vertical direction to find the VA. In this case, upward directions become positive, meanwhile downward direction become negative. So, equal to VA plus VC. If you refer to this one, VA going up or upward directions and VC also upward directions. That's why both reactions become positive. And then minus 40 times 3 are this point load. This UDL, point load from this UDL. So we get the horizontal, we got vertical reactions at A is 88.33 kilonewton. Finally, we take the sum of the forces in the horizontal direction to find the HA. So, HA minus 20. HA, if you refer to this one is clockwise, this one is rightward direction, that's why it is positive. Meanwhile, for horizontal reaction at the leftward directions, that's why it is negative, negative 20. So, horizontal reactions at A become 20 kilonewton. For the calculation of member forces, we use the method of joint. First of all, we need to look for the joint does not have more than 2 unknown forces. In this truss, we find that joint A has only 2 unknowns. Now we take a look at this joint, joint A. In the beginning, we assume that all the unknown forces as tensile. Now we go to joint A, and this one is free body diagram at joint A. It consists of 2 members, AB, member AB, and member AE connected to joint A. It has 2 reactions applied to this joint A, VA and HA. So look at this free body diagram. So if this one, we have 2 unknowns, FAE or force for member AE and force for member AB. If you refer to this one, FAE is inclined force. We need to find this angle first. Using Pythagoras Theorem, we can identify the angle. Okay, this one is theta. We assume as theta 1. If you refer to this one, this angle, theta 1, vertical distance is 2 meter and horizontal distance is 2 meter. So you can find the theta based on this theorem Pythagoras. So from this theorem Pythagoras or Pythagoras theorem, we find that we got theta 1 is 45 degree. The force in member AE is making an angle of 45 degree with x-axis, therefore it has to be resolved into its rectangular components along y-axis. So it becomes FAE sine 45 degree, and along x-axis become FAE cos 45 degree. Since we want to identify the AE or force in member AE, we use vertical equilibrium equation. So equal to FAE sine 45 plus VA, or 88.33 kilonewton. So first, for member AE is negative 124.92 kilonewton. Negative indicates that the member in compression, or the force for member AE should be in opposite sense, or the other words, it is compressive force. Next, we need to find force for member ED. If you refer to member ED, this member it is subjected to a uniformly distributed load of 40 kilonewton at certain specific distance only. Okay, at 3 meters from E only. Okay, firstly, we have to convert this uniformly distributed load to point load which loaded at center of this UDL. Okay, so this one become 40 times 3. 40 times is distance, so is 120 kilonewton per meter. Sorry, 120 kilonewton only. Okay. After that, we need to transfer the point load to joints E and D. Okay, this one need to transfer to joint E and also joint D. Now look at this member. Okay, I'm using this step to determine loads at joint E and D. Okay, let's say this one is the member E, joint E, and this one joint D, and this is the load of 40 kilonewton per meter. Distance from E to D is 8 meter. Meanwhile, distance from E, for this UDL is 3 meter only, and then the rest become 5 meter. Alright, I need to calculate point load at joint E and point load at joint D. By using equilibrium equation, we can calculate point loads at E and D. Firstly, I take moment at D equal to 0. So equal to PLE, point load at E, times distance from E to D of 8 meter, minus the UDL 40 times 3 is point load at center of this UDL, and then distance from the point load to point D is 3 over 2 plus 5. So PLE equal to 97.5 kilonewton. And then using vertical equilibrium equation, I calculate PLD, where equal to PLE, point load at E, plus point load at D, minus 40 times 3. So point load at D equal to 22.5 kilonewton. Now turn back to this truss. So point load at E become 97.5 kilonewton. Meanwhile, at joint D, 22.5. If you refer to these values, of course logic, because joint E will receive highest load compared to joint D. Okay, because this UDL close to joint E. Now turn back to this free body diagram. So we have one external load at joint E with a value of 97.5 kilonewton. We have an inclined force of FAE and FEB, and we have horizontal force of FED. So at this joint we have two unknowns. The first unknown is ED, FED, force for member ED, and second is force for member EB. If you refer to this one, FED in horizontal directions. So firstly, you need to count FEB. You need to calculate FEB first. However, for the FEB, this one is inclined load or inclined force. So you need to find this angle or this theta. So this theta, let's say theta 2 equal to tangent inverse 2 over 4. So that's why theta 2 equal to 26.56 kilonewton degree, sorry, 26.56 degree. Okay, now we use vertical equilibrium equation to determine FEB. So, okay, turn back to this one first. The force in member EB is making an angle of 26.56 degree with the x-axis, therefore it has to be resolved along y-axis, so become FEB sine 26.56 degree, and this one along x-axis become FEB cos 26.56. For this one, FAE for the vertical or y-axis become FEA or FAE sine 45 degree. Meanwhile, for the horizontal become FAE cos 45 degree. We look for the first vertical equations. So equal to FEA sine 45 for this one, negative because downward directions, minus FEB sine 26.56 degree minus 97.5. So FEB is negative 20.506 kilonewton. So the value is negative. It indicates that the member in compression. Now we go for this equilibrium equations, horizontal equilibrium equation to determine FED. So equal to FED, this one positive because rightward directions, minus FEA cos 45 plus FEB cos 26.56 for this one. So FED is negative 106.67 kilonewton. Negative indicates that the member in compression. I hope you enjoy studying this example. After we calculate force for member ED and member AE. Okay, for the next session, I will show you how to determine internal force if the member is subjected to a triangular load at certain distance only, and maybe combination between triangular load and point load or uniformly distributed load at certain distance only, and how you transfer the UDL or triangular load to joint, to the selected joint.